are different types of operating systems. Single user, single tasking. Single user, multitasking. Multi-user, multitasking. Real-time operating systems. Very few different possible categorizations for operating systems. One of the most common categorization relates to the number of users and tasks it can support at any time. Single user, single tasking refers to operating system that can support only one user at a time and only one program being run at any time. This is the characteristic of old operating systems like MS-DOS. Single user, multitasking refers to operating system that can support many programs running at a time, but allow only one user to use the system. An example is Windows 98. For example, it will allow a user to listen to music while burning a CD. Multi-user, multitasking refers to operating system that in addition to being multitasking, can support more than one user working on a computer at any time. How is this possible? The users will connect to the computer through a network and, from there, launch applications that are executed by the computer. Examples would be Linux, Unix, and Windows 2000 Server. Real-time operating system are operating system found in industrial machines where tight control on what is happening is crucial. It does not have a GUI. It is mostly concerned with input and output management. It is a multitasking operating system that aims at executing real-time applications. Real-time operating systems often use specialized scheduling algorithms so that they can achieve a deterministic nature of behavior. The main object of real-time operating systems is their quick and predictable response to events. The world of personal computers is dominated by the Windows operating system from Microsoft. Yet, it is not the only operating system in existence. Many computers are running Linux and Mac operating system as well. Several examples of operating systems are DOS. Initially, Microsoft started with MS-DOS, a command line operating system. It was a single tasking operating system developed for single user. In DOS, we had the famous C prompt like C:\\, where users would type in commands on a black screen. Only one program at a time can use such OS. DOS provides various functions for programs like displaying characters on screen, reading a character from the keyboard, accessing disk files, and more by typing command line. Unix was designed to be portable, multitasking, and multi-user in a time-sharing configuration. Unix systems are characterized by various concepts. The use of plain text for storing data. A hierarchical file system. Treating devices and certain types of inter-process communication, IPC, as files. And the use of a large number of software tools. For some time, this was good, but the whole setup was not at all user-friendly. Eventually, after some time, an operating system with a graphical user interface was introduced by Microsoft bearing the name Windows. Windows 3.1 was one of the first versions released, and it had very crude graphics compared to modern operating system, but at that time, hardware was not powerful and it would have been hard to support elaborate graphics. Eventually, Microsoft moved to Windows 95, which was quite a revolution in terms of GUI and user-friendliness. No more would the computer start to a black screen. Now, a nice graphical user interface would welcome the user. Macintosh. Most recent versions are based on Unix, but it has a good graphical interface, so it is both stable, does not crash often, or have as many software problems as other systems may have, and easy to learn. One drawback to the system is that it can only be run on Apple-produced hardware. BIOS. The BIOS stands for basic input-output system. It is found in the ROM of the computer and is the first piece of software that is run by the computer. The initial function of the BIOS is to identify, test, and initialize system devices, such as the video display card, hard disk, and floppy disk, and other hardware. This is to prepare the machine into a known state so that software stored on compatible media can be loaded, executed, and given control of the PC. When the computer is powered on, the power supply is started. It will take some time for the power to rise to a stable value, and once it is done, the processor is started. The first thing it will do is load the BIOS from the ROM. How does it know where to get the BIOS? This is hard-coded into the processor, and the start address of the BIOS is always stored at the same address in the ROM. The BIOS program provides a small library of basic input and output functions that can be called to operate and control the peripherals such as the keyboard, text display functions, and so forth. The BIOS will then carry out a series of tests to determine if the memory, processor, graphics card, and others are operating properly, that is, power on self-test. It usually emits a series of beeps if something is not right. After testing the different components, it will display a summary and then attempt to load the operating system. This figure shows the interface of a BIOS. The BIOS will look for a device to boot from. A computer will normally boot from the hard disk, but that setting of the BIOS can be changed to allow booting to take place from a floppy disk, or CD, or DVD drive instead. Drivers. A driver acts like a translator between the device and programs that use the device. Each device has its own set of specialized commands that only its driver knows. It is a computer program allowing higher-level computer programs to interact with the hardware device. To be able to talk to the different peripherals like keyboard, printer, graphics card that are attached to a computer, the operating system needs an interface. That interface is what is known as a device driver. Therefore, a device driver simplifies programming by acting as an abstraction layer between a hardware device and the applications or operating systems that use it. However, most drivers for standard peripherals like the keyboard and mouse are now already available in the operating system and do not need to be installed. The new peripheral is simply connected and it is immediately recognized. This is what is called plug and play. Utilities and service programs. In computers, a utility is a small program that provides an addition to the capabilities provided by the operating system. In some usages, this program is a special and non-essential part of the operating system. The print utility that comes with the operating system is an example. It's not absolutely required to run programs, and if it didn't come with the operating system, you could perhaps add it. These programs do some general housekeeping tasks. They take care of some simple but yet essential tasks like formatting a diskette, that is, erasing everything found on a diskette, and defragmenting a hard disk. Normally, these utilities will become bundled with the operating system, but some special software like Norton Utilities can also be used to do these. Translators. The computer understands only zeros and ones. This is called the machine language. So, when giving instructions to a computer, we should talk to it in terms of zeros and ones. However, humans are not very good at that, and so we write programs in high-level languages which resemble English. But, having done so, we need to convert these instructions to zeros and ones, and this is where the translators come into play. Basically, this translation is performed by either a compiler or an interpreter. A compiler takes a whole program, that is, the source code written in a high-level language, and converts it into an object code, which is basically machine code. The object code can then be processed by a linker, which will link the object code with some other object file to allow it to execute independently. If there are any errors during the compilation process, a list of errors are generated, else the program is available for the linker to make an executable file out of it. Hence, a compiler translates the entire program into machine language before executing any of the instructions. An interpreter will convert each line of a program as needed into machine code form as it is being run. So, the program will require the interpreter to be present on the machine at all times when it is going to be run. Moreover, since each line is being converted to machine code as the program is being run, it usually takes longer to execute a program with an interpreter compared to compiling it in one go. Hence, an interpreter translates and executes a single instruction or small groups of instructions at a time.